Okay, so this topic is about group 1 metals. Okay, group 1 metals. Now, before I carry on, I would advise everybody to watch the introduction to chemistry video in which I'm doing practicals with my year 9 class, because you get to see for yourself what I'm talking about. We actually go through and put the metals into water, and we watch the reactions and we talk about them, and the year 9s make some really good observations, so it's well worth watching, I think. Okay, so obviously groups go down, so this is all of these are group 1 metals, and what you need to be aware of is that the reactivity of group 1 increases as we go down the group. So this one is reactive to start with, but this one here is the most reactive. However, typically in classroom situations we only go up to potassium. Anything beyond potassium is too dangerous for schools. Okay, so and like I said, guys, check out that video because we show it and it's all there. So what we've got is we've got lithium, sodium, potassium. Okay, and these are all going to react with water. Now, with water, we can test the pH of water using universal indicator solution, and this will give a green color because it is pH 7, which means that the water is neutral, right? Then what we've got is when we add lithium, we're going to add this to the water, right? And it's going to make a salt. It's going to make lithium hydroxide plus some hydrogen gas. Now let me talk about this hydrogen gas for a bit. I'm just going to get rid of the periodic table for now. This hydrogen gas, we can make a test for hydrogen gas. You should know this really from C1. However, I'm going to go through it again. With hydrogen gas, you take a lit splint and you put it into the hydrogen gas sample. So you're going to put that into the hydrogen gas, and then it's going to make a squeaky... Ooh, what happened there? It's not cool. It's going to make a squeaky pop sound. Okay, so that's the test for hydrogen gas. Now, this bit here, this lithium hydroxide, is alkaline. So it's alkaline, and so it's gonna change the color of the universal indicator. Remember, it's green to begin with, but it's gonna change it to a blue/purple color. Okay, we'll just stick with blue. It's gonna change it to a blue color, and this is gonna tell you that the solution has changed from neutral, from when it was just water, to alkaline. Why? It's because of this lithium hydroxide. Now, if you look at the video, if you watch the video, what you're going to notice is that lithium itself is a solid, water is classified as a liquid, the lithium hydroxide is now in solution, so this is going to be aqueous, and finally the hydrogen is gas, so that's going to be in the gaseous form, so we need that G symbol. Okay, and now I'm just going to get rid of everything, and I'm going to go through the chemical equation for it, okay, and how to work it out. So what we're going to do is we're going to write out the word equation first. So it's a lithium plus water makes lithium hydroxide plus your hydrogen gas. And remember, squeaky pop test for this, hydrogen gas. So lithium is Li plus water, you should all hopefully know, is H2O. Now lithium hydroxide is going to be LiOH. Okay, so it's your metal plus your hydroxide. Hydroxide is OH plus your hydrogen gas. Hydrogen gas is always H2. So now what you're going to do is you're going to balance the hydrogens first. So I've got 2 here and I've got 2 here, right? So that's a problem straight away. So what we're going to do is we're going to put a 2 here to balance this hydrogen. So now I've got 4 here and I've got 2 here. right? So I've got 2 times 2, which is 4, 2 here, and so I'm going to put a big 2 in front of this, and so that'll give me 2 times 2 hydrogen, that's 2, well sorry, 2 times 1, because there's 1 hydrogen here, so that's 2 hydrogens, plus this 2, so in total I've got 2 plus this 2 makes 4, so I've got 4 hydrogens on this side. Next I'm going to check if my oxygens are balanced, so yeah, my oxygens are balanced, so that's 2 on this side. Let me just highlight it for you guys. So I've got 2 oxygens on this side, I've got 2 oxygens on this side, so my oxygens are balanced. And finally I'm going to check my lithiums. So let's see, with my lithium, I'm going to check this. So lithium I've got 2, but I've only got 1 here, so I need to put a 2 in front of that. And now everything is balanced. Now guys, what I find that works is first balance the hydrogens, then check the oxygens, then do everything else, whatever else is left. This always works for some reason. So let's now try the next metal. So after lithium it's sodium, so I'm going to write the general word equation. We're going to write sodium plus water makes sodium hydroxide, and it all follows the same patterns, guys. Sodium hydroxide plus your hydrogen gas. So sodium has the symbol Na, we know that from our periodic table. Water has H2O. Our equation is going to be NaOH, because that's sodium, and this is the hydroxide bit. OH, remember, stands for hydroxide, plus your hydrogen gas. Now let's put the state symbols in, guys. This is something that we didn't do in the previous one. So this is a solid, this is a liquid, this is in solution, so it's aqueous, and this is the gas that's being given off. Now let's balance it again. Same rules, guys. First you're going to balance the hydrogen. So I've got 2 here, I've got 2 here. However, that's not enough, because we're going to, well, I've got 2 here. Can you see I've got 2, and I've got this 1 here, and I've only got 2 here. So what I'm going to do, I'll make this 4 on this side and 4 on this side. So this is 2, so now I've got 4 here, but I've still got my 3. So 2 plus 1 is 3, so I'm going to put this here. So now if we compare this here, I've got 2 hydrogens here, 2 hydrogens here, so that's 4, and I've got 2 times the 2 hydrogens, that's 4 hydrogens. So my hydrogens are balanced. Next we're going to check the oxygen. The oxygen, in this case I've got 2 oxygens, and I've got 2 oxygens here, so my oxygens are balanced, so I can just tick that off. And finally everything else. So this is, what is everything else? It's really the sodiums. So I've got 2 sodiums here, only 1 here, so I'm going to put a big 2 there, and that is balanced. Now let's do it for, what shall we do it for now? We'll do it for potassium. So if I've got potassium, right, plus my water, it's going to make potassium hydroxide, plus my hydrogen gas. Guys, again, look, it's all the same pattern. Now excuse me while I rub this rubbish off. So this rubber on this software is a bit rubbish, to choose a better word. So I've got my hydrogen gas, I've got this reaction happening, happy days. So let's have a look. Again, potassium is K, we know that from the periodic table. Water is H2O, which makes K, that's the potassium. OH is hydroxide, plus your H2. Let's balance this now. I've got 3 hydrogens here, 2 there. So I'm going to make this 4, I'm going to make this. So I've got 2 plus this 2 here. I've got 4 hydrogens on both sides in total. My oxygens are balanced. I've got 2 potassiums here. I need 2 potassiums here. Balanced. Brilliant. So again, like I said, guys, all of these hydroxides, so the potassium hydroxide, sodium hydroxide, lithium hydroxide, they are all alkaline, so they're going to make the universal indicator turn blue. Now I just want to go back to the periodic table and talk a little bit more about some of the physical properties. Okay, So like we said, guys, this is in terms of the periodic table, in terms of its reactivity. When you're comparing them, lithium is reactive but not as reactive as francium, so it gets reactive as you go down, the reactivity increases. So the question is, well, what would you see? And this is a common question, okay? And now you would see quite a few things, and if you check out that video that I was talking about, you'll see it there. Number one is that they start fizzing, right, and floating fast on top of the water, right? And like I said, you'll see a color change in the water because of the universal indicator. The hydroxide, lithium hydroxide, sodium hydroxide, potassium hydroxide are pH alkaline, so they're going to make the water turn blue. Right, what would you see now with lithium? Lithium makes a red flame, right? Sodium, that's the would you eat yellow snow? Now you wouldn't, makes a yellow flame, right? So if you drop in the sodium into water, it's going to make a yellow flame. And potassium, this is the killer, which is lilac, makes a lilac flame. So these are the unique features that you'll see in each case. Now I've also seen like a safety precaution question, which is like, what safety procedures should you take if you're doing this experiment? Well, there are a few. Number one, as always, you need your goggles, right? And number two, you need a safety screen. You will see in my video that I have a safety screen, really to protect the audience from any explosions that might happen in that process, or if the glass breaks or anything like that. So that's all of that. Now, one final thing that I want to say, and this is something that one of my year 9 students watched the video. One of my year 9 students spotted. What she said is that, sir, why is it easier to cut? Because she noticed that I was struggling with this one. By the time I got to potassium, it was easy to cut. And basically that's one of the characteristics that you need to know. As you go down the group, the metals become easier to cut. So as you go down group 1. Now finally, the last kind of thing is, once you cut the metals, they are quite shiny, and then they end up reacting with the oxygen in the air and become dull again. And so I believe this is everything to do with group 1. I don't think I've left anything out, so I'm happy with that. Hopefully this makes sense to you guys.